Hello, pre-algebra students. This lesson video is going to be all about ratios. It's our fourth lesson in our first unit. For our warm-up, since you're taking notes, make sure you title your page in your notes ratios. And then I've got these two warm-up questions for you to go ahead and try. It'll help us with our conversation that we're going to be having today about ratios. Go ahead, pause the video, and try those two questions now. All right, so for this first one that asks you to simplify the fraction 12/16. In earlier lessons, we've talked about simplifying fractions. It involves us finding a common number to divide by. Here, in order to simplify this fraction, you could divide by 2 twice, or the biggest numbers you could divide 12 and 16 by is 4, and that gets you to that simplified fraction 3/4. When we talk about simplifying fractions, 12/16 and 3/4 are the same amount. Simplifying fractions just makes the numbers in the fraction smaller, but it's still the same fraction. In the other question, we are trying to find the missing numerator. Remember, numerators are what you call the top number in the fraction. So we're given the fraction 2/5, and I want to figure out 2/5 is equal to what fraction over 20. For this question here, it's similar to simplifying fractions where we're trying to find an equal fraction. The difference here is the math we're going to use to do it. Simplifying, we were using division, but if I wanted to go backwards, so if I wanted to start with the smaller fraction and get those larger numbers, I would be using multiplication. I would be taking 4 times 4 to get 16 and 3 times 4 to get 12. So here I'm going bigger. I just got to figure out what that number is that I would need. In this case, it also happens to be 4. It's not always 4. But looking at that pair of numbers I do have, I see 5 times 4 gives us 20. And then for our numerators, to find that missing numerator, I'm just going to do the same thing. I'm going to do 2 times 4 and get that missing numerator of 8. The math we are doing here with fractions is going to be similar to some of the math we're doing today when we talk about ratios. Our goal for ratios is 2 parts. The first part is we're going to talk about how you write ratios. In order to do that, we'll first start off by talking about what a ratio is, and then we're going to talk about finding equivalent ratios. In earlier lessons with me, we've seen this word before. Do you remember what equivalent means? When I see that word equivalent, it sounds to me like the word equal. We are talking about equal ratios. Similar to the idea up above, when we were saying 12/16 equals 3/4, those are equivalent fractions. Same right here, 2/5 and 8/20 are equivalent fractions. We're going to be talking about equivalent ratios in this lesson. So those are our 2 goals for today. To start off, we said we're going to start off with a definition of ratios, since that's what today is all about. So our new vocabulary, and you want to make sure you're writing this down in your notes, a ratio is just a comparison of 2 numbers. A ratio is a comparison of 2 numbers. Now that's our definition, but I think an example helps a lot with what we actually mean by a comparison of 2 numbers. So to start us off, we're going to talk about a recipe and how that recipe relates to ratios. To start us off, this will be our first example. And in this problem, we've got Denise is making punch for a party, and the recipe calls for 3 times as much fruit juice as Sprite. There are 2 ingredients here. There is fruit juice and there is Sprite. But recipes normally aren't written this way. It says a recipe calls for 3 times as much fruit juice as Sprite. I want to think about that in a different way. Usually recipes have like 2 quantities, 2 amounts for each of those ingredients. We can take this sentence here and reframe it in our brain with 2 numbers. I'm going to have you look down at this little quote bubble down here. When I say the recipe calls for 3 times as much fruit juice as Sprite, how much fruit juice are we adding and how much Sprite are we adding in that recipe? See if you can fill in those two blanks in this quote bubble here. Like we said, a recipe normally is going to give you an amount of fruit juice and an amount of Sprite. And when we say the recipe calls for 3 times as much fruit juice as Sprite, that means for every 3 cups of fruit punch, there is 1 cup of Sprite. That would mean there's 3 times as much fruit punch. 3 times means we're talking about some multiplication here. For every 1 cup of Sprite, there are 3 times as much fruit punch. There is 3 cups. So, when we are talking about ratios, we said a ratio is going to be a comparison of 2 numbers. And here are those 2 numbers. Those 2 numbers are 3 and 1. When I go to write my ratio, it's going to be important that I'm using this question here to help me out. So it says I want a ratio of fruit juice to Sprite. My first number in my ratio is going to be how much fruit juice we're adding. And we said we're adding 3 cups. So my 3 will come first. And then my Sprite will come second. We said 1 cup of Sprite, so I'm going to put my 1 right here. And the new part for today, when we're writing ratios, we use this symbol right here to write it. That symbol is called a colon. So my ratio would look like 3, and then I'm going to put my colon right there, and then a 1. I would read that out loud as 3, and then that colon right there, we read using the word 2. So I would read it as 3 to 1. That ratio means this down here. It means for every 3 cups of that fruit juice, there's going to be 1 cup of Sprite. The next part of this is going to be creating a table with all of the different combinations Denise can use with this recipe to make her fruit punch. So one of those combinations is what we had just said. We said she could do 3 cups of fruit juice and 1 cup of Sprite. That's what we had started off with. That's our starting ratio. And that would give her a total of 4 cups of liquid to serve for her party. But if you've ever followed a recipe before, you know this is the starting recipe, right? But if we wanted to make more, so 4 cups of punch is not enough for a party. So if we would want to make more, how do we use this original recipe to help us create more punch? For example, maybe Denise wants to make double. She wants to make twice as much punch as this recipe calls for. How much fruit juice and how much Sprite would she need to use if she wants to make twice as much punch? When we say twice as much, when we say doubling, all of those are talking about multiplying by 2. I could take our original recipe, our original ratio, and I could double it. I could multiply that original recipe by 2. When I do that, twice as much fruit juice would now be 6 cups of fruit juice, and twice as much Sprite would be 2 cups of Sprite. That would give us twice as much punch. There would be a total of 8 cups of punch there. So I could double that recipe, and that looks like me multiplying both numbers in my ratio by 2 to get twice as much. Now that was Denise doubling the recipe. What if Denise wanted to triple the recipe? Go ahead, pause the video, and see if you could come up with what that third row in our table would look like if she wants to triple. Well, tripling means we're now not doubling, we're multiplying by 3 for tripling. If she wants to triple this recipe, that would mean she needs 9 cups of fruit juice and she needs 3 cups of Sprite, and that would give her a total of 12 cups of punch. Now I'm changing how much she's using. The original recipe, like we said 3 cups of fruit juice and 1 cup of Sprite. So when I'm tripling it, I'm definitely using more ingredients. Would these two taste the same? Would the punch taste the same if I follow this recipe or if I follow this recipe? What do you think? Yeah, it's all based on the same recipe. Each of these have the same idea of there's 3 times as much fruit juice. For this third one we just wrote, there's 3 times as much fruit juice here as there are Sprite. That's multiplying by 3 there. The only difference is how much. The only thing that's changing is the total cups we're getting, but it's all based from that same initial recipe and that same initial ratio. I encourage you, go ahead, pause the video one last time and see if you can come up with another possibility down here for another possible combination of fruit juice and Sprite Denise could use to make this punch. My guess is a lot of you followed this table. So you had 3, 6, 9, and we have her quadrupling. That's multiplying by 4 and getting to 12 cups of fruit juice and 4 cups of Sprite for a total of 16 cups. And that would be a great row to have on our table. Please know, though, that that is not the only thing we could fill in this table with. Maybe Denise knows she is a very popular person and she's got a lot of people coming to this party, and even 12 cups of fruit juice and 4 cups of Sprite isn't enough. Maybe she knows she needs a lot. And maybe she knows that she purchased 30 cups of fruit juice. Maybe she knows that's what she already has and she wants to use it all. How could we figure out how much Sprite? Well, just like we've been multiplying by 2 to double, multiplying by 3 to triple, you can multiply by any number. So maybe she wants to use 30 cups of fruit juice. That would be her multiplying by not 2, not 3, not 4. 3 times 10 would give us 30. So she is making 10 times the amount of punch this recipe calls for. That would mean multiplying the fruit juice by 10 and doing the same thing for the Sprite. So if we're multiplying the fruit juice by 10, we need to multiply our Sprite by 10, and that would give us 1 times 10, give us 10 cups of Sprite for a total of 30 plus 10. That would be 40 total cups of punch for this party. Looking at this last row here, the same thing is true. There is still 3 times as much fruit juice as there is Sprite. There's just a whole lot more punch. The goal of this first part here was to see how we write a ratio. That's up here with part A. And then just seeing some of the possibilities of what we can do with these ratios. Think of it like a recipe that we need to follow. You can double the recipe, you can triple the recipe, but we need to keep the balance between those ingredients the same throughout all of these. Now, there's one last part for this. Before we get to that last part, I do want to show you some pictures to go with what we've been talking about. So when we say 3 times as much fruit juice as Sprite, that's like this. We've got 3 cans of fruit juice for that 1 can of Sprite. All she's doing in this table is creating more punch. So if I wanted more than this makes, I could double it. And if I double it, that means I've got like 2 of those pictures from above. Now I've got 6 cans of fruit juice and 2 cans of Sprite. Or if I wanted even more, what would I want to add to? It's still going to be that base of adding 3 cans here of fruit juice for every 1 can of Sprite. So if I wanted to create even more, I could add 3 cans of fruit juice and 1 can of Sprite for a total of 9 cans of fruit juice and 3 cans of Sprite. Or if I wanted to keep going, what do you think the last picture is going to be? How many cans of fruit juice? How many cans of Sprite? Well, I have to keep it balanced, right? So I've got to keep the original recipe. It means every single time I add 3 cans of fruit juice, I'm adding 1 can of Sprite. So my last picture is going to look like this. for a total of 12 cans of fruit juice and 4 cans of Sprite. It's this idea of we want to keep the same ratio. We want to keep the same recipe. And so if I need to make more, it means I have to keep adding 3 cans of fruit juice at a time and adding 1 can of Sprite at a time. Now, one last question with this, and then we're done with the fruit juice and Sprite. The last question is really about what ratios are. And so when we were looking at all these problems, we were working with a ratio of 3 to 1. If I come back to that original ratio we wrote, we said the ratio of fruit juice to Sprite is this ratio of 3 to 1. The question I want to ask now is that ratio the same as the ratio 1 to 3? Why or why not? Pause the video for however long you need to think about this question and see if you can figure out, are those ratios the same or not? Well, when we wrote this original ratio of 3 to 1, it was to answer the question, write the ratio of fruit juice to Sprite. And so based on that question, we came up with 3 to 1, meaning 3 cups of fruit juice for every 1 cup of Sprite. When we've talked about this in class, well, some people will say, well, 1 to 3 is just you've changed the order of the ingredients you're adding. A recipe can say 3 cups of fruit juice and 1 cup of Sprite, or it could say 1 cup of Sprite and 3 cups of fruit juice. But here, when we think about the ratio of 1 to 3, remember when we had written this original ratio, it said fruit juice to Sprite. It means that first number is talking about fruit juice, and then that second number is talking about Sprite. So when I look at the second ratio, would 3 cups of fruit juice and 1 cup of Sprite be the same as creating a punch based off of 1 cup of fruit juice for every 3 cups of Sprite? And the answer there is no. If you think about making these 2 different punches, they would taste different because they're using different recipes. You could definitely make a punch with 1 cup of fruit juice for every 3 cups of Sprite, but they wouldn't taste the same, is the key idea here. So when we're talking about ratios, the order you write those numbers in your ratio is really important. And I'm going to write that down, and I encourage you to write it down in your notes as well. The key here is the order of the numbers in a ratio is important. When I was looking at that question, write the ratio of fruit juice to Sprite, I had to list the number of cups of fruit juice first and the number of cups of Sprite second. Because when we're working with this ratio, there's no more words anymore, right? I'm just looking at 3 to 1. So the only way I know what that 3 and what that 1 are talking about are from this question here. So I can't just switch around those numbers. Now I could ask you to write the ratio of Sprite to fruit juice, and that would be the ratio 1 to 3. That means the same thing as what we were doing earlier. 1 can of Sprite for 3 cans of fruit juice. That's what I see up here. 1 can of Sprite to 3 cans of fruit juice. The key here, though, is following the order of what is listed in the question. If I ask you for the ratio of fruit juice to Sprite, it means that first number better be your fruit juice and that second number better be your Sprite. We cannot switch around the order of numbers and ratios. So for this first part of our lesson, our hope is you are leaving this part of the video feeling confident with what ratios look like, what they sounds like. Notice each time I'm reading these ratios out loud, I'm saying 1, 2, 3, 3, 2, 1. And that's the word 2, not the number 2. And then, like we said, getting a feel for what you can do with ratios. You can, in this case of a recipe, you can double or triple them, keeping the recipe the same and just getting more of that amount. That idea there is what we're going to explore more in this next part where we talk about equivalent ratios. So for our next part on equivalent ratios, I've got more about food. And in the second example here, we've got Kimmy loves ice cream, and she notices the Kroger ad below. Use the information in the ad to fill in the table. In this ad, there is a ratio that's given to us. Now, if you've seen this before in an ad, I'm sure your brain doesn't say, yes, a ratio. But when they tell us 2 tubs for $5, that is another example of a ratio. We said a ratio is a comparison of two numbers. And what we're saying here with that ratio of 2 to 5 is we're saying you can buy 2 tubs of ice cream for a total of $5. So for the first part of this question, I am trying to fill in this table, and that's where I can start. I can start by saying you can buy 2 tubs of ice cream for a total of $5. And using what we know now about writing ratios, if I wanted to write the ratio of ice cream tubs to cost, because remember, paying attention to the order those words in is important, I could write, well, there's 2 tubs of ice cream for a cost of $5. For every 2 tubs of ice cream, it costs me $5. Similar to what we were doing above, there's a couple more rows in this table. See if you can come up with some other pairs of numbers we could include in our table. Go ahead, pause the video and do that now. So another one of your rows in your table, maybe you said she wants double this. She wants twice as much ice cream that's in this picture. So we could double that. We could say, well, she wants 4 tubs of ice cream. So that's like 2 of these pictures. She wants another, oh God, those are tubs of ice cream. So she wants another pair of tubs, and that would cost twice as much. That would cost $10 and would leave us with a ratio of 4 to 10. For every 4 tubs of ice cream she buys, she pays a total of $10. And we could keep doing that. But I want to point out she loves ice cream. So 2 tubs, 4 tubs, even 6 tubs isn't enough for her. Maybe Kimmy wants to buy 20 tubs of ice cream. I'm curious, if she wanted to buy 20 tubs of ice cream, could you figure out how much that would cost? Well, think about the math we were doing earlier. Everything is going to be based on this initial ratio we had, this ratio of 2 to 5. If I want to get 20 tubs of ice cream instead of 2, how much more ice cream is that? It's not twice as many. It's not triple the amounts. It's all about multiplication. What am I multiplying that initial ratio by? You can always use division to help you figure it out. I know 20 divided by 2 is 10. So that means 2 times 10 is giving me 20. Once I figure out that, I can do the same thing over here. So this picture, it's like she's buying 10 of these pictures. She's buying 10 times as much as in the ad. So that means the cost is going to be 10 times as much. It means that cost of $5, I want to multiply that by 10 as well, because these are always going to be the same. And 5 times 10 gives me 50. I guess let me keep the colors consistent. So we get that ratio 20 to 50. That means for every 20 tubs of ice cream she's buying, it would cost her $50. Now we know the ad isn't ever going to say 20 tubs of ice cream cost $50. But I do want to compare these two for a moment. Are these the same deal? Are you getting a bigger discount with one of these? Take a moment and think through that. Well, when the ad says 2 tubs of ice cream for $5, that means that each one of these tubs of ice cream is going to cost how much money? If I say 2 tubs cost $5, it means each tub, this was not the correct color to use, each tub cost $2.50. We can figure that out using division. So that's $2.50 each. When we say 20 for $50, yes, of course, that is a ton more ice cream. But if you do that same division, you're getting the same deal here. If I divide the $50 by 20, that's also $2.50 each. One of these other ones we had figured out, that 4 to 10, if we do that division, it's also $2.50 each. So similar to when we first started with the recipe of Sprite and fruit juice, we said each time we were just making more punch, but the recipe was staying the same. Here, what's staying the same is this idea of how much each tub of ice cream costs. We're scaling up, meaning she's buying more and more ice cream, but it's all for the same original price. Each tub costs $2.50, no matter how many tubs of ice cream you buy. So as I'm filling out this table, you've already paused the video and came up with a couple more combinations. If you wanted to check yours, you should be able to divide it out and see that each tub costs $2.50 each. Or you should be able to show me what that common number is you're multiplying by. You can choose any number you want. So maybe your favorite number is 9, like me. You could take that initial ratio and multiply it by 9. If we do that, that puts an 18 here. But the key is whatever you're multiplying that first number in your ratio by, you've got to multiply that second number in your ratio by as well. If you're getting 9 times the amount of ice cream shown in this picture, the cost is going to be 9 times as much. Meaning here, 5 times 9, the cost would be $45. Now for each of these, we've been writing ratios for them. I've got 2 to 5, 4 to 10, 20 to 50, 18 to 45. Coming down here for this question at the bottom, look at all of those ratios. What do all of those ratios have in common? Take a moment to think about that. Well, one thing they all have in common is we had mentioned earlier about this $2.50 each. They all are describing the same deal or price for ice cream. If you're buying 18 tubs of ice cream for $45, it's not like you're getting a better deal. You're still paying the same amount for each tub of ice cream. You're just getting more ice cream. So they're all describing that same deal or price. When we have all of these ratios here, because they're all describing the same relationship between how many tubs of ice cream you're buying and the cost, we could say that all of these ratios here are equivalent ratios. Now, we started off this lesson talking about that word equivalent. We said equivalent ratios are equal ratios. They're all ratios that are describing that same relationship. And here's our other vocabulary word. Equivalent ratios are going to be 2 or more ratios that describe the same relationship between 2 numbers or 2 amounts. So earlier when we were doing that question about fruit punch and Sprite, all of those different rows in our table were equivalent ratios. They all were talking about the same recipe, just more fruit punch than other ones. Here, these are also all equivalent ratios because they're all describing that same deal that we saw in the advertisement. It's just certain rows mean you're buying more ice cream. So in general, if I give you a ratio like 2 to 5, how can you find other equivalent ratios? Maybe I give you this ratio and it's not about ice cream or tubs of ice cream and price anymore. Maybe it's just me giving you a ratio and asking you, find an equivalent ratio. What math could you do to find more equivalent ratios? The key here is going to be multiplication. Multiplication. I'll go back up to our table. Remember, the key here is we've just been using multiplication. When I was using the word double, we were multiplying by 2. When I said triple, we were multiplying by 3. But you can multiply by any number just as long as you're being consistent and multiplying your entire ratio by the same number. So the second part of that question said find other equivalent ratios that aren't already in our table. If you take that initial ratio of 2 to 5, pick any number and just use multiplication. So if I wanted to multiply that ratio by 5, 2 times 5 is 10, and 5 times 5 is 25. That would be an equivalent ratio. If I want to take that initial ratio, 2 to 5, and I want to multiply it by 10, 2 times 10 gives me 20. Ooh, that's not a 20. 2 times 10 gives me 20, and 5 times 10 gives me 50. If I want to take that initial ratio and multiply it by 25, 2 times 25 gives me 50, and 5 times 25 gives me 125. Now, in the story, that would be you buying 50 tubs of ice cream for $125. But the key here is all of those are the same ratio. All of those are describing the same relationship between how much all of that ice cream is going to cost. The key here is multiplication. We are just taking that original ratio and multiplying it by a number. I choose 25. 2 times 25 gives me that 50, and 5 times 25 gives me that 125. You're using multiplication just to make sure those are the same. So using this idea of multiplication and how we can use that to help us find equivalent ratios, there's one last part to this, and that's going to be exploring this idea of equivalent ratios a little more. It says with a partner, I'll be your partner. So for this last part, we've got Joe took a long multiple choice vocabulary test. The ratio of the number of problems Joe got wrong to the number of problems she got correct is 2 to 5. Let's talk about what that ratio means in this context. The ratio of number of problems she got wrong, the number of problems she got wrong, to the number of problems she got correct is 2 to 5. That means if she misses 2 problems, she got 5 problems correct. And I'm going to use this ratio language that we've been hearing a lot. It means for every 2 problems she gets wrong, she gets 5 problems correct. I'm saying for every 2 problems she gets wrong because we don't know how many total questions are on the test. It says it's long, but I don't know how many questions that is. It's going to look something like this. If she misses 2 problems, it means she gets 5 questions correct. And just like our recipe could double or triple, just like that advertisement for ice cream, you could expand that even more. I don't know how many questions there are, but I know if I see 2 that are incorrect, it means there should be 5 correct. So if the test was short, it would look like this, but it says it's longer. So it might be something like this, where there's a total of 714 questions. She misses 2, she gets 5 correct. She misses 2, she gets 5 correct. And it doesn't even have to be in that order. So maybe it looks something like this. She misses 2, gets 5 correct. Misses 2, gets 5 correct. This next row here, she's missed 2 and gets 5 correct. This next row here, she's missed 2 and gets 5 correct. It just means if I see 2 X's, if I see she's missed 2, I should be able to match that up with 5 correct answers. That's what this sentence right here about the ratio of questions on the test means. For every 2 questions she gets wrong, there should be 1, 2, 3, 4, 5 she gets correct. So based on that, we can answer some questions. First, if we are told Josie missed 8 questions, how many did she get correct? Just like with the recipe for the punch and the ad in Kroger for ice cream, it's all going to have to do with that initial ratio we were given. Our initial ratio was 2 to 5, and it might help us to label this. In that ratio, the 2 went with the number of problems she got wrong, and the 5 went with the number of problems she got correct. So let me do some color coding here. The 2 was the one she got wrong, and the 5 was the number she got correct. For every 2 she misses, she gets 5 correct. The question is saying if Josie missed 8 questions, that 8 is how many she got wrong. So I'm going to put it here. And we are trying to figure out how many she got correct. I'm trying to figure out this number here. I'm trying to find out what that equivalent ratio is. And we said earlier the key. What math am I going to use to do that? I'm going to use some multiplication. So here I'm taking my 2 and asking myself, what number do I have to multiply by to get to 8? Remember, you can always use division to help yourself out. I know 8 divided by 2 is 4, so that must mean 2 times 4 gives me 8. Let's just do the same thing on this side. 5 times 4 is going to give me that missing number. That means if she got 8 wrong, she must have gotten 5 times 4, 20 correct. And that actually happens to be what I showed up here in this picture. Notice she got 1, 2, 3, 4, 5, 6, 7, 8 wrong. And if you count up all those green check marks, feel free to pause the video if you want to do that. You're going to see she got 20 correct. Because there's 5 in this first row, 5 in the second row, 5, 10, 15, 20. So that was us doing this first part here. If I asked you to explain how you got your answer, I would explain this multiplying 4 that we did. We could say I needed to multiply the original ratio by 4 to get 8 to 20. That means if she misses 8 questions, she got 20 correct. The key, I think, in this explanation is tell me about that 4 that you used to find that equivalent ratio. Now, we did that one together. Go ahead, pause the video and try B. B is a little different because now I'm giving you a number of questions she got correct and asking you to use that to help you figure out how many she missed. Try this one now. I'm going to set it up the same way we did up above. So I'm looking at that ratio of how many questions she got wrong to how many she got correct. We're given that initial ratio of 2 to 5. And in this question, I'm given a number of questions she got correct. So that 45 questions correct, I'm going to match it up right here. That 45 goes there. We're trying to figure out this number here, how many she got wrong. I've got this pair of numbers over here, so I can use this to help me figure out what I'm going to need to do to figure out that number on the left side using, same as above, some multiplication. This time, though, I'm not multiplying by 4. What would I need to multiply by to get the second ratio? Well, I know 5 times 9 gives me 45. Do that same thing over here. 2 times 9 gives me 18. She got 18 questions wrong if she got 45 questions correct. What all of these have in common is they would all work out to the same grade because you're getting the same percent of questions wrong and the same percent of questions correct. We're just changing how many total questions there were on all of these. One last thing I want to point out is I can connect this back to what we did at the very beginning on your warm-up. So if I scroll all the way up here, remember I asked this question about finding the missing numerator in that fraction? And this idea of when we talk about simplifying and equivalent fractions, it's all about just using multiplication to help you find that equivalent fraction. We're doing the same thing here. It's just instead of talking about fractions, we're talking about ratios. But it's the same idea of you're multiplying by the same number and your numerator and your denominator to get that equivalent fraction. Down here, and I'll scroll. Down here, it's the same idea. We're multiplying by that common number, 9 in this case, to find that equivalent ratio. There's a lot of ways those two things are similar. The last part of this, we've already talked about that they're equivalent ratios. The last part is just coming up with another possible ratio. It goes back to this idea of equivalent ratios and how we can find them. See if you can come up with one more equivalent ratio here that would work out to the same idea of for every 2 questions she gets wrong, she gets 5 correct. What's another possible ratio? Remember, it's all about multiplication. I'm not sure what number you chose, but as long as you pick a number to multiply on both sides to get your new ratio, it would be equivalent. So maybe you choose the number 10. We could say 2 times 10 is 20, and 5 times 10 is 50. That would be equivalent. Or maybe you chose, for this to be a very long test, and maybe you chose the number 100. 2 times 100 is 200, and 5 times 100 is 500. As long as it's that same number on both sides, it's going to be an equivalent ratio. What about the ratio 2 to 5 and the ratio of 40 to 100? What do you think about that one? Well, I would just want to check the math. So 2 times 20 gives me 40, so that's okay. And 5 times 20 gives me 100. I was multiplying by the same number on both sides, so that means they are equivalent. That could also be a possibility. But if I had given you something like this, 40 to 400, well, now on that left side, we're multiplying by 20. On our right side, 5 times 80? Yes. 5 times 80 gives you 400. Now they're not the same, so that would not be equivalent ratios. There's a question similar to that on the homework for today. That is everything I've got. I hope you find this video helpful for introducing ratios. Our lesson tomorrow, which also is the last lesson of this unit, is going to be on unit rates, which relies a lot on our understanding of ratios. So I hope that you're leaving this lesson feeling much more confident on ratios than you started off with. Thanks so much for watching. Bye.